So today we're going to be talking about alternative sources of energy. We've been looking at all the different types of energy and how important it is, and particularly how much we rely on electricity, which is of course electrical energy. So we have to make sure that we're going to have enough energy to meet all of our needs. That's not going to happen unless we can find what's called alternative sources of energy. So our lesson intentions are that by the end of this lesson you will be able to offer an explanation for why we need to have alternative sources of energy. You'll also be able to talk about the advantages and disadvantages of what is renewable and non-renewable energy sources. As said previously, you're not expected to do the whole PowerPoint at one time. You can do a few slides and then take a break and then come back to it. You do have summary notes as well, and they will also highlight some of the key points here as well. So, where do we get our energy from? That's right, we switch on. But where does that come from? Yes, that's right, we have pylons, electricity pylons. We've all seen them before. We also have electricity underground now as well. But how does that get there? How does all the things that we rely on that use electricity, our phones, our televisions, our laptops, our game boxes, all of these things rely on electricity. Where is electricity from? How is it made? And how does it get into our houses? So here is a slide which puts it all together quite simply. Electricity is actually generated in a power station or a power plant. For example, Hunterston is a power station, and that's where electricity is generated. It's then changed into a high voltage in order to be transmitted or to be carried, if you like, for long distances. And these are the big pylons that I'm sure that you've seen. Once they get into neighbourhoods or smaller areas, the energy has to be then reduced in order for it to then go into our homes so that the voltage is not too high. So these are all things that you will have seen, but that's actually all how electricity is first of all generated and then carried or transmitted into our homes. So what happens in a power plant or a power station, sorry. So there is a YouTube video for you to watch. You just need to click onto the slide and it'll tell you much more detail what exactly happens inside one of these massive structures called a power station or power plant. So why do we need alternative sources of energy? Currently, we use what's called fossil fuels. 84% of the world's energy supplies come from fossil fuels. That's where we get our energy from. Fossil fuels are coal, oil and gas. They were formed over millions of years ago from dead plants and animals. This means that they took a long time to form, and when they run out, there will be none left. We often say that fossil fuels are finite, which is, if you think about it, the opposite of infinite. It means that they will run out. So what would we do then if 84% of our energy comes from fossil fuels? We've already looked at how electricity is generated in a power station, and the majority of our power stations are coal. That means when coal runs out, what else can we use to produce electricity? So that's why we need to talk about alternative sources of energy. Another word we can use for that is what's called renewable. Fossil fuels are non-renewable because they will run out. We have to look for renewable energy sources, ones that won't run out. So how much longer do we have fossil fuels for? As I said previously, we're talking about coal, oil and gas. And just like the dinosaurs are no more, our fossil fuels will also run out too. We do sometimes find new supplies, particularly of oil. However, this is not reliable and it's not sustainable, particularly when you think about how much we depend on our energy sources. Remember, 84% currently of our energy comes from fossil fuels. If we keep burning our fossil fuels, remember coal, gas, oil, particularly things like coal when you're burning it in power stations. If we continue this at our rate, it's generally estimated that all our fossil fuels will be gone by 2060. That's less than 40 years. So we have to really think about looking after the fossil fuels that we have, but also looking for those alternative energy sources, those renewable energy sources that we talked about. So if fossil fuels are so precious, then how come we're going through them so quickly? It's easy. Everything's already established. We're used to using our cars. We're used to being able to use other forms of transport. We're used to going on foreign holidays. It's going to take some effort. It's going to take some time in order to find alternative energy sources that are renewable. There is a big push, as you know, for electric cars. Electric cars do still need to have electricity, which of course can come from fossil fuels. However, they don't produce as much pollution as burning fossil fuels directly do. And that leads us to another issue with using fossil fuels. Remember, fossil fuels are coal, oil and gas, and all of them contain the element carbon. When you burn carbon in oxygen, you produce carbon dioxide gas. Now, carbon dioxide gas is not harmful to us. We breathe out carbon dioxide gas, of course. However, it is harmful to our environment because there's so much fossil fuels being burned that there's an increase in the levels of carbon dioxide gas in our atmosphere. This leads to something called the greenhouse effect and global warming. Of the three fossil fuels, coal gives off the most carbon dioxide gas when it is burned. And remember, we looked at power stations when they were generating electricity, and many of our power stations still burn coal. So that's going to give off increased levels of carbon dioxide gas, which then will rise up in our atmosphere and, as I said, impact by leading to the greenhouse effect and global warming. So what do we mean by the greenhouse effect? When fossil fuels are burned, they produce carbon dioxide gas. They also produce water vapour as well. Methane is an example of a greenhouse gas too. And the three of these combine to be called greenhouse gases. They rise up into our atmosphere, and what they do is they stop heat from escaping into space via infrared radiation. This means that the atmosphere heats up. Now, even a 1 degrees rise in temperature will have a big impact on our environment. It will cause global warming. I'm sure you've seen pictures of icebergs and glaciers melting, and then that impacts on our climate. So we have freak changes in weather. We also have increased flooding. We could have increased droughts. It's all related to the global warming. It's called the greenhouse effect because if you've ever been in a greenhouse, it's like a structure made of glass, and gardeners use it to grow plants because it's warmer inside the greenhouse because the glass is able to absorb the sun, the light energy. And in a way, that's what's happening to the earth because we are warming up, and that's why it's referred to as the greenhouse effect. So the next slide has got a little bit more detail, or a lot more detail in it, for any of you future physicists. It's not needed for any kind of assessment. However, it just goes into a lot more detail as to what happens with infrared and ultraviolet radiation. So here we go. There are various types of electromagnetic radiation. We'll find out more about that when you're in the second year. You will have heard of it because you'll have heard of some of them, for example, ultraviolet or UV, which is a form of electromagnetic radiation. It's actually one of the ones that comes from the sun, and it's why you have to wear your sun cream to protect yourself from that because it's damaging. Anyway, this radiation passes from the sun through the Earth's atmosphere. The Earth absorbs electromagnetic radiation with shorter wavelengths and so warms up. Heat is radiated from the Earth as something called infrared radiation. Some of this infrared radiation is then absorbed by the greenhouse gases in the atmosphere instead of escaping out into space, and this is what causes the atmosphere to warm up. This is what we called in our previous slide the greenhouse effect, which causes global warming, which causes climate change. So what is an alternative source of energy? It's an energy source that can be used instead of fossil fuels. It's usually a renewable source of energy that could be used when fossil fuels run out. There is a YouTube video for you to watch which goes into more details about all the different types of alternative sources of energy or renewable sources of energy that you can get. So one of the alternative energy sources to fossil fuels is nuclear power, nuclear energy. In Scotland we have two nuclear power stations, one at Hunterston and one at Torness. There are about 15 across the UK and there are just over 400 around the world. They use something called uranium, which is radioactive, and a small amount of uranium metal can produce a huge amount of energy. It's also considered a cleaner energy because it doesn't produce the greenhouse gases that we mentioned earlier, carbon dioxide and water vapour. However, what it does do is it produces radioactive waste. Now, radioactive means that it is dangerous, it can cause cancers, it can lead to death, and it will remain radioactive for a long time, hundreds of years. So therefore it has to be stored very carefully, and that's a big difficulty, a big challenge for nuclear energy. Also, because nuclear energy can produce so much energy, it has to be very safe and secure. So if nuclear power is now too risky, what are our other sources of renewable energy sources, ones that will not run out? Hopefully you'll recognise some of the pictures here. On the top right we have solar panels, and that of course is absorbing the sun energy and changing it into electricity. These are solar panels. Underneath we've got wind turbines. Scotland is fortunate perhaps because we are able to use wind turbines because of our weather. We're able to turn all of that energy, all that wind power, and turn it into electrical energy as well. There's also research into waves and tides and how we can harness that energy and turn it into electrical energy. These are all examples of renewable energy sources because they won't run out. They are also cleaner because they're not producing any pollution gases. However, how reliable are they? If you don't have an environment or a weather with wind, then the wind turbines couldn't work. Solar panels in Scotland, not always going to be working efficiently. However, that's where we've got to spend our energies, our time, and making these renewable energy sources work as best as they possibly can. So some of the disadvantages of renewable energy sources is, as mentioned earlier, is how reliable they can be if they're dependent on the weather, for example the sun. Also they are huge and they do impact on the environment in terms of how it looks. Some people don't want their scenery to be changed, they don't want to look out and see wind turbines. However, we have to measure that with the fact that we're getting all of this energy and we are not harming our environment with pollutant gases. So here's a summary of all the advantages of using these renewable sources of energy. They are inexhaustible because they're also available, they are renewable, they're clean, they don't produce these greenhouse gases which impact on our atmosphere. Some people may say that they impact on the scenery, however we have to measure that with the good that they do by giving us energy without all of the pollution. There are various types. We've looked at winds and solar energy. There's also hydroelectricity, which we use in Scotland. There is research into tidal and wave power as well. So it can be adapted to whichever country and its climate. Most natural sources also can be used on a smaller scale, so they serve local needs. If you think about the previous slides where we looked at all these big electricity pylons which cut across the country, carrying electricity from power stations all around the country. There wouldn't be such a great need for that if it was kept more local and meeting the local needs.